Review on recent advances in VLSI Multiplier. Abstract low-power very large-scale integration, VLSI, circuit is vital criteria for designing an energy-efficient design for prime performance in the compact device design. Multiplier plays an important role for planning the energy economical processor that determine the potency of the processor. Multiplier has important role in DSP, DIP, microprocessor, and microcomputer application. Among all the arithmetic operation that exist, a processor consumes most of the time and hardware resources for carrying out multiplication when compared to other operations like addition and subtraction. In this review, array multiplier, Booth multiplier, modified Booth multiplier, Wallace tree multiplier, and modified Booth-Allace tree multiplier have been reviewed considering several performance parameters, such as speed, area, power consume, circuit complexity. The fast multiplier is desired in any application. While comparing various multipliers, it has been observed that the selecting an appropriate multiplier for any application is always a trade-off between speed, power, and the area. Array multiplier has the largest delay and low power consumption and have large area, while Booth encoded Allace tree multiplier has least delay and it also have large area. In above multipliers, one of the limitations is no of partial products. The Booth algorithm for multiplication overcomes the limitation and hence, the performance is improved. In this review, the Booth algorithm and its variant which outperform the several multipliers will be discussed. The detailed comparison of multipliers and their performance matrix in term of delay, area, and power consumption will be provided, so that the most appropriate multiplier can be chosen for application. Keywords: array multiplier, Wallace tree multiplier, Booth multiplier, modified Booth multiplier, low power VLSI. Introduction. The multiplication is an important central function in arithmetic logic operation in several applications such as digital filtering, digital communication. The faster device with low power consumption is the demand of every consumer. High-speed components of the device and reduce the power consumption leads to enhanced performance. These days, the demand of portable electronics modules is on rise in which various digital signal processing, DSP, are used. Therefore, the compact and the faster multiplier plays a vital role in designing such modules when the computational performance of a DSP system is limited by its multiplier performance and Multiplicand dominates the execution time of most of the DSP algorithms, and therefore high-speed multiplier is desired with an ever-increasing quest for greater computing power on battery-operated mobile devices too. The design emphasis has shifted from optimizing conventional delay time, area, size to minimize power dissipation. Therefore, for maintaining the high performance, the speed and area of multiplier are major design issues and they need to be optimized for enhancing performance. 3. The architecture of multiplier can be split into 3 stages, namely, partial product generation stage, partial product reduction stage and the final addition of the reduced partial product stage. Traditionally, the shift and add algorithm have been used to perform the multiplication 7. However, it is not suitable for faster multiplication in VLSI because it requires a greater number of adder units which leads to higher delay in performing multiplication operation. Some of traditional approaches for speeding up multiplication operation is reducing the number of partial products by using multi-bit compressor 8. Multiplier can be classified into 2 categories, namely, serial and parallel multipliers. In a serial multiplier, each bit of multiplier is used for evaluating the partial product, whereas in parallel multiplier, partial products from each bit of multiplier are computed in parallel. The main parameter that determines the performance of the parallel multiplier is the number of partial products that is to be added. In a parallel multiplier, the speed is compromised to achieve better performance in terms of area and consumption. 8. Depending upon the type of application, the parallel or the serial multiplier can be used. Some of the known parallel multipliers are array multiplier, Wallace tree multiplier, Booth multiplier, and modified Booth multiplier. These multipliers are discussed in following text, keeping focus on Booth multipliers. Booth multiplication algorithm treat both signed and unsigned numbers. The main use of Booth algorithm is to reduce the number of partial products by reducing the number of multiplier bits. It is used in different recoding scheme as radix 2, radix 4, radix 8. In Wallace tree algorithm the number of sequential adding stage is reduced, which is used for improving speed. Modified Booth algorithm also reduces the partial product 7. Array multiplier. Array multiplier is a regular structure multiplier. Array multiplier is digital combinational circuit used for multiplying 2 binary number by employing an array of full adder and half adder. This multiplier perform multiplication by the standard add and shift algorithm. The partial product is generated by multiplying the multiplicand with each bit of the multiplier. The partial product obtained are then shifted depending on their bit order and are finally added at the last stage. The number of partial products that are generated is equal to the number of multiplier bit. Array multiplier has very regular and systematic structure. Its delay becomes very large for a large word length. Min C. Park et al. 1993, 4 presented a new architecture using dual array tree structure, which include dual partial product array divided from one partial product plane of conventional array multiplier. Array multiplier consumes more power and optimum number of components required. It requires larger number of gates, and therefore the area also increases. So, the array multiplier performs poor in terms of area 3. It is a fast multiplier but hardware complexity increases due to the large number of gates. The schematic representation of conventional array multiplier with CSA is shown in Figure 1. Wallace tree multiplier. A Wallace tree multiplier is a hardware implementation of digital circuit that perform multiplication of two binary number. Wallace tree multiplier are devised by the Australian computer scientist Chris Wallace in 1964-1. The Wallace tree multiplier lessens the number of partial products and use carry select adder for the addition of partial products. Wallace tree is an irregular in structure in which informal implementation does not supply the systematic method for the compressor interconnection, still it is an efficient method of adding partial product in parallel for. In this method, three-step process is used to multiply two integers. There are two different designs of Wallace tree multiplier. The first one is considered using only half adder and full adder while the second one uses a more sophisticated carry skip adder, CSA. At the initial step, partial products are formed by multiplying each bit of multiplicand by each bit of multiplier. So, the number of partial products is determined the length of multiplicand 2. Half adder is used in each column where there are 2 bits and full adder is used in each column where there are 3 bits in column. Any single bits in column is passed to next stage in the same column without any operation. This reduction procedure is repeated in each successive stage until only 2 remain 3 in the final stage, the remaining 2 rows added. After completing all the 3 stages we get 8 bits output. The schematic example is shown in Fig 2. Speed, area, and the power consumption of the multiplier will directly be proportional to the efficiency of compressor. The compressor, 3:2, is used to make overall multiplier faster. A Wallace tree using 3:2 compressor, 3 partial products are passed to 1 bit full adder which is called 3-input Wallace tree circuit and output of signal is applied to next stage full adder of the same number of bit located is 1 bit higher position 1. Wallace tree is tree having carry save adder are arranged as shown in Fig 3. A carry save adder, CSA, consists of full adder, but carry output from each bit is brought out to form second result vector rather being then wired to the next most significant bit. The carry vector is saved so that it can combine with some later. The schematic representation of Wallace tree multiplier is shown in Fig 3. Wallace tree multiplier. The purpose of CSA is to improve worst-case path delay 5. A 4-bit is used for implementing CSA. The carry output from first addition is the carry input in the second addition. The advantage of CSA is to increase the maximum frequency 9. The Wallace tree multiplier using CSA occupies smallest area. In the Wallace tree method, due to irregular structure, layouting the circuit becomes more complex although the speed of the operation is high, since the circuit has an irregular structure. Booth multiplier. This algorithm was devised by Andrew Donald Booth in 1950. While doing study on crystallography, Booth used reception desk calculators that shift faster than adding and formed the algorithm to increase the speed. It treats both signed and unsigned numbers. The flowchart for Booth algorithm is provided in Fig 4. It is extremely prevailing algorithm for signed number multiplication, which considers both positive and negative number uniformly 10. An algorithm uses 2's complement presentation of signed binary number for multiplication 8. Each multiplier bit generates one multiple of the multiplicand that should be added to the partial product. In this case, the delay of the multiplier is mainly governed by number of additions to be performed. If there is way to reduce the number of additions, the performance will be better. It is the standard technique used in chip design and provides significant improvement over the long multiplication 7. The schematic flow chart of Booth algorithm is shown in Fig 4 and application of Booth algorithm shown in Table 1,2 step by step. Procedure. M is the multiplicand. Q is the multiplier. Consider 1-bit register Q1 and initialize to 0. Consider register A and initialize to 0. Condition. Modified Booth multiplier. Another improvement in the multiplier is by decreasing the number of individual partial products. To achieve high-speed multiplication, algorithm using parallel counter like modified Booth algorithm has been demonstrated and practiced. It reduces number of multiplicand and number of partial products 8. It groups 3 consecutive bits at a time, in that 3-bit 2 bits on left-hand side are present bit and third bit is the carry bit from previous pair of bits. The multiplier operates much faster than array multiplier for longer operands because its time to complete the operation is proportional to the log of the word length of operand. The main benefit of this multiplier is that if the successive bits in multiplicand are same, then addition can be skipped 6. The number of partial products is downed by a factor of half by using the technique of Booth recoding 7. The grouping of bits and Booth recording determine the number of partial products. In a given multiplier, the group of 3 bits are considered. It initiates from the LSB bit and first group is formed by 2 bits. Onward consider a group of 3 bits in which 1 bit will be overlapped on the previous group as shown in figure 4. Thus, group's multiplier will result in the production of bits between these 5 bits are as follows: -2, -1, 0, +1, and +2, which are tabulated in table 3. Consider the scheme of radix 4 Booth multiplier. A demonstrative example of multiplication of 2 number is described below. Assuming the integers 10 and 5, the multiplication results into 50. The multiplicand along with its binary equivalent and multiplier along its binary number are. Algorithm 1. Check whether the multiplier and multiplicand are having negative sign. If so, convert 2's complement. 2. Add implied 0 to the multiplier and then convert the multiplier into other form using Booth recoding table shown in above table. 3. Now multiply the multiplier with multiplicand. A. If the multiplier was 0, then the multiplicand multiplied with 0 will result in the output is 0. B. If the multiplier was +1, then the result of the multiplicand with the multiplier was same as the multiplicand. C. If the multiplier was -1, then the result was calculated by 2's complement of the multiplicand. 4. Finally add all generated partial products adders. The figure 6 shows the block diagram of modified Booth algorithm. The partial product generator PPG generates the partial product from the multiplicand and encoded multiplier 6. The partial product obtained at the output of PPG are then added by PPRT without carry propagation. Finally, the summed result obtained from PPRT stage are added using carry propagation array CPA. 7. Conclusion. In this article, various types of multipliers have been reviewed considering the performance parameters and complexity of design. The results from different sources are tabulated in Table 3. It can be observed that the trade-off between the various performance parameters should be made while selecting the multiplier for some application. In terms of complexity, array multiplier outperforms all the multipliers while the speed is relatively the lowest among all. If we consider the power consumption of multiplier, which is the most important parameter, in the case of a portable devices, modified Booth algorithm excels among all the discussed multipliers.